Okay, so we are going to start talking about properties of images formed by concave what? Mirrors. So we are going to look at it in different cases. Why are we going to look at it in different cases? Now, it is not like in the case of plane mirror where we just wrote down 5 properties and that is all. So in the case of plane mirrors, when we wrote down those 5 properties, the properties does not change no matter where the object is. But in the case of concave mirror, depending on where the object is, the image position will change. And since the image position will change, the properties of the image will also what? Change. So we are going to look at different scenarios of where the object can be placed in front of a what? A mirror. So let's look at case 1. Case 1. And in case 1, we are going to have our object is beyond C. So our object is beyond C. Remember when we talked about terms used in mirrors, I told you that C is the center of what? Curvature. So object is beyond the center of curvature. So what does that mean? Now look at this. I will draw my mirror. This is my concave mirror. And then I draw my principal axis. This is my pole. Now I will put F. This is my point F. And I measure equal distance and put my 2F or my C, which is the center of what? Curvature. Now, I will put my object at a point that is beyond the C. Remember, they said object is beyond the C. So I put my object at this point. Then I draw a line. I draw a line from the object straight to the mirror. Like that. So I will draw that line. Once I draw that line, next thing, this line is going to pass through where? F. Because remember, after reflection, the lines will pass through F. So this guy will pass through F like this. Okay? Then the second one will go to the mirror, and then of course it will pass through C. Second one will pass through C. Okay? It will pass through C. It will pass through C. It will pass through C, and then gets reflected back. Okay, but we can just use here. Let's just use here to make it simple. Let's just keep it at this point. Okay, so I will draw the second line to touch the mirror. Now imagine, look at where the two of them intercepted. So this line and this line, look at where both of them intersected. Okay, now because they intercepted at this point, that is where our image is formed. Anywhere they intercept, that is where our image is what? Is formed. Now look at this now. If you notice, the two lines intercepted below the principal axis. And because they intercepted below the principal axis, our image will be pointing down. So look at the arrowhead of the image pointing down. Arrowhead of the object here pointing up. Arrowhead of the image pointing down. Why is it pointing down? Because they intercepted below the principal axis. Now after drawing this, next thing I have to do is to find the properties of the image formed. Properties. So properties means let us describe this image. So what is the first thing? Remember, our object is beyond the C. So where is our object? Our image formed. Our image is formed between C and F. So we can say image is formed between C and F. Okay? Between center of curvature and the principal focus. So between C and F. That is the first one. Number 2, we can say that the image is inverted. We can say that the image is inverted. Why did we say inverted? Because it is upside down. Image is inverted. Image is inverted. Then number 3, what can we say? When the image is inverted, the image is real. So image is real. Then number 4, of course, if you look at the object and look at the image, who is bigger? The object is bigger. So we can say that the image is what? Diminished. So image is diminished. Image is diminished. And that is that for this first case. So observe. Make sure you observe this. So you see that image is inverted. Image is real. Now, because our image is real, it means that if we are trying to use that equations that we talked about earlier, if we are trying to use the equation earlier, for this case that the image is real, we are going to use plus. So we are going to have 1 over F equals 1 over U plus 1 over V, because the image here is what? Is real. Now, Take note of that. Now what happens? Next thing, in case 2, so we are going to move the object closer. We'll move the object closer. This time around, object is at C. Object is at C. Object is at C. So if we put the object at C, let's see the property we are going to obtain. So I draw this principal axis, and then principal focus, and then this is C. Okay, so I come to C and put my object. Draw this line to touch the mirror, second one to pass through F. Now, because we cannot make it to go and pass through F, we are going to borrow F for now. So we make it to pass through F and then bounce back and come back here, bounce back here. Okay, so this is looking okay for us. It is looking okay for us. So we are going to talk about the properties. So properties. The first property we are going to see here is that, okay, let's use this one as our base. Image is formed between C and F. Where is the image formed here? It is formed at C, exactly. Of course, if I use rulers and all that and draw to scale, you see that it will be formed at where? At C. So I can say that image is at C. Image is at C. Number 2, they said image is inverted. Is our image inverted here? Yes, of course, image is inverted. It is the other way around. So we can say that image is inverted. Number 3, is the image real? Yes, it is real. So image is real. Number 4, is the image diminished? No, it is not diminished. Is it magnified? No, it is not magnified. So what is it then? It is the same size as the object. And if it is the same size as the object, what do we say? We say that magnification is 1. Magnification is 1. Magnification is 1. So that is the properties we get from here. So as you can see, image is real again. And because it is real, we use plus. Let's look at the next one, case 3. Let's see what is going to happen, or the properties we are going to obtain when we are in case 3. So in case 3, our object, we are getting closer now. Our object is between C and F. Let's see what is going to happen. Let's see what is going to happen. So our object is between C and F. This is F. And this is C. So object is between C and F. So let's see. So I put an object here. Then I draw the line. This guy passes through F. Now, of course, this one can pass through C because C is free now. Okay? So this one will pass through where? C. It will pass through C. You see that when it passes through C, look at where both of them intercepted. This is where they intercepted. So look at this. This is our image. So let's talk about the properties. Let's talk about the properties. So number one on the properties, look at where is the image formed. We can say that the image is beyond the C. It is after C. Okay, so we can say that the image is beyond C. That is where it is formed. Number 2, is the image inverted? Yes, it is inverted. Image is inverted. The next one, is the image real? Of course it is real. The next one, is magnification 1? No, magnification is not 1. Is the image diminished? No, it is not diminished. It is what? Magnified. Look at our image. It is bigger than our object. So we say that the image is magnified. Image is magnified. Those are our properties. Let's quickly move on to case 4. Let's move to case 4 and see what is going to happen there. Case 4. Case 4. So in case 4, where is our object now? Our object is at is at F, at principal focus now. So we are coming closer. Object is at F. Let us see what is going to happen. So object is at F. So I draw this. This is F. This is C. So I put my object at F, draw this line, draw this, then draw this. Now you can see that if I extend this side, both of them appear not to be meeting each other. If I even extend it on this side, they also not appear to meet each other. So the two lines are parallel, and because they are parallel, it means that no image will be formed. But how do we write it technically? Okay, property here, the only property is that the image is at infinity. Image is at infinity. Don't forget that. JAMB will ask you this question: what is the property of the image formed by an object when the object is placed at the principal focus? Know that the image is at what? Infinity. That is case 4. And then case 5, which is the final case under a concave mirror. Case 5 under concave mirror. Let's see what it is going to look like. Let's see what it is going to look like. Let's see what it will look like. So case 5. And where is our object now? We can say objects between F and pole. Between F and pole. The object between F and what? Pole. So this is our pole. This is our F. And this is our C. So I place my object between both of them. So let's draw. Okay, this guy here, and then this one, draw this to enter here like this. So you see that they are appearing to scatter on this side. But if I extend it, it's as if they are intercepting somewhere here. So look at it now. Look at our image. So take note of what is happening there. First things first, where is the image formed? It is formed behind the mirror. So we can say that image is behind the mirror. That is where it is formed. It is behind the mirror. Second one, is it inverted or is it upright? It is upright, of course. So look at the object, upright. Image is also upright. Why is the image upright? Because, of course, they intercepted above the principal axis. So image is upright. Number 3, we can say that if the image is upright, it is what now? It is virtual. So image is virtual. Image is virtual. So this is more like what happens when you stand in front of your mirror. So image is virtual. And then number 4, is it magnified or diminished? It is magnified. So image is magnified. Image is magnified. So those are our properties. And if you look at this, pay attention now. In the concave mirror, look at our image is virtual here, meaning that if a question like this is given, we use 1 over F equals 1 over U minus 1 over V. So take note of that. So because in case 5 the image is virtual, so we are going to use minus. In case 5 image is virtual, so we are using minus. That is what we are using. So take note of that, because the image is what? Virtual. Because the image is virtual.